All right, let's jump right in. When we talk about securing AI, our minds usually go to hackers trying to bust through firewalls after the thing is already up and running. But what if I told you the biggest threat isn't the locked front door, but a crack in the foundation it was built on? That's what we're digging into today, this huge, often missed vulnerability in AI security.
So let me ask you, where do an AI's biggest risks really begin? Is it out in the wild once it's deployed, or when some attacker starts poking at it? Well, the answer might not be what you think. It's got less to do with what happens to the AI later on and everything to do with what was put inside it from the very start.
Yep, that's it. The most dangerous, most stubborn flaws are often baked in right at the beginning, during design and training. This is the moment an AI is learning, soaking up data like a sponge, and it's also the very first chance for it to learn all the wrong things, creating vulnerabilities that could stick around for its entire lifespan. So let's break this down into what I'm calling the 3 foundational flaws. I want you to think about it like you're building a massive skyscraper. If that concrete foundation has cracks in it from day one, it doesn't matter how fancy the penthouse is, the whole thing is at risk. It's exactly the same with AI.
First on our list is data poisoning. An AI model is only ever as good as the data it's fed. So what happens when that data is, well, poisoned? If an attacker slips malicious or just badly biased samples into the training set, the model learns the wrong lessons. It's literally like feeding the AI a toxic diet. It gets corrupted from the inside, creating these huge, dangerous blind spots.
Next up, we've got model manipulation. Now this is a whole lot more direct. This isn't just about poisoning the food source. This is like a saboteur getting onto the construction site and messing with the rebar. Malicious actors, heck, maybe even an insider, can get in and directly tweak the model's internal wiring, inserting hidden backdoors or programming it to respond to secret triggers.
And the third flaw is something called model drift. This one's a bit slower, but it's just as dangerous. See, the real world is always changing, but an AI that was trained on old data, it's basically stuck in the past. Over time, its performance starts to degrade, kind of like a foundation slowly eroding from the elements. It gets less accurate, and worse, it becomes predictable, which is a goldmine for attackers.
Okay, so if the problems all start in the foundation, it makes sense that the solutions have to start there too. This brings us to the first line of defense: secure development. This is all about building a strong AI with a secure blueprint from the get-go, not just hoping for the best.
And a secure blueprint means being super careful at every single step. It kicks off with the architectural design, picking a model that isn't way more complex than it needs to be. Then you've got dataset selection, which is way more than just grabbing a bunch of data. It's about carefully curating and cleaning it. And maybe most importantly, that training pipeline itself has to be locked down tight to stop that tampering we were just talking about.
This slide really lays it all out, doesn't it? The difference between the two paths is just night and day. On the insecure side, you see all these shortcuts, like grabbing a black box model from a third party without having a clue what's actually inside it. But the secure way, that demands verification, a clear supply chain for your model. It's really the difference between building on a total mystery and building on solid, verified ground.
So you've built the model, great. But is it actually secure? You can't just cross your fingers and hope. You have to test it. And that's where the evaluation phase comes in. It's basically a stress test, designed to find all the weak spots before the bad guys do.
And listen, we're not talking about a simple checkup here. A real evaluation has to cover all the bases. You've got to test for adversarial robustness. How does it hold up when it's actively being attacked? You have to check for fairness and bias, making sure it isn't making weird, skewed decisions. And you absolutely have to actively test it against data you know is poisoned to see how it reacts. Bottom line, you have to try to break it in order to make it stronger. And this really gets to the heart of it. If you don't evaluate your AI properly, you are essentially just leaving the doors and windows wide open for an attack. You are creating the exact kind of blind spots that sophisticated attackers are actively looking for. An incomplete evaluation, that's almost as bad as doing no evaluation at all.
All right, on to the final stage before this thing goes live: validation. If evaluation was the stress test, think of validation as the final certificate of occupancy. It's the official sign-off that says, yes, this AI is safe and ready for the real world. And this is the million-dollar question that validation has to answer. Sure, a model might work perfectly in a sterile, controlled lab environment, but can it handle the messy, chaotic, and often hostile conditions of the real world? When the stakes are high, can we actually trust what it's telling us?
Just look at the direct line between these checks and the disasters they prevent. Human-in-the-loop testing isn't just some buzzword. It's what stops an AI from confidently making up nonsense, hallucinating during a critical security incident. Setting up guardrails and verifying prompts, that's what stops a prompt injection attack from turning your own AI against you. Every single one of these checks is a critical barrier against a specific, real-world catastrophe.
So if you take one thing away from our chat today, let it be this. Real, effective AI security is not an add-on. It's not a patch you apply later. It's a core principle that has to be woven into the AI's DNA from the very first line of code and the very first byte of data. It is all about building it right from the ground up.
Which leaves all of us with one last, pretty critical question to think about. The AI systems that we're starting to rely on for, well, everything, are they built on solid ground? Or are we, without even knowing it, putting all of our trust into systems that were built on foundations that were cracked from the very beginning?